Students, in the previous video session, you have gone through the friction and its types, the static friction and the kinetic friction. Also, you have gone through the salient features of kinetic friction and static friction. So, let us discuss about pushing or pulling. So, let us see. To move an object, push or pull, which is easier. So we also know that in our daily life we are using we are doing this thing. Suppose we want to move the table or in our house a bed or some cupboard. So anything we are moving means maybe we will push that object or we will pull that object. We know that if we are pulling or pushing, that object can move. Now based on this, we can see that which one is easier. If you want to move the table, a heavy table is there, you want to move that heavy table. So how you can move easily, that is what we can see. So we know that we all know that if you are asking these questions to the students, suddenly they will say that pushing an object is easier. Actually, in this concept, we will understand that which will be easier. Let us see an diagram for that. Assume that this is so this is what assume that this is a ground surface, and on this ground surface you have kept an object like this. Assume that on a floor, on table is there. We know that when the object is at rest, there are two forces acting. There is what forces? Downward gravitational force is acting, and upward straight line. So upward normal force is acting. So downward gravitational force is acting, upward normal force is acting. Now this object is at a rest. So now you are applying a force at an angle theta. So this is what a force is applied. We know that assume that you are standing and you are pushing this object. So before pushing this object, you know that the normal force is equal to what? Mg. That is what is happening before pushing this object. Now you are applying an external force, additional force F at an angle theta on this object. So what happened means, due to this now here it is making an angle theta, so that this F can be resolved into two components. One is F cos theta and another one is F sin theta. So you see here one force is applied at an angle theta on this object. Now this force is resolved into two components, F cos theta and F sin theta. And this F cos theta is a perpendicular component and F sin theta is a parallel component. So now you see, now by using this you can draw a free body diagram. Now what will happen means, before drawing the free body diagram, you go through this. You see, when we are applying this force at an angle theta on this object, it is splitting. So downward what is happening means, downward F cos theta force is acting. So along with this mg there is a force, no, which is acting downward also. Now what is this? F cos theta. Now you see downward force is acting is F cos theta, also this mg. So these two forces are acting, which is in the downward direction. So upward is only what? N. Before, when the object is at rest, I told n is equal to mg. Now you see, now n is equal to what? This mg also there, f cos theta also. So that you can write the equation what? N normal force equal to now what? Now the normal force is equal to mg is there, also f cos theta is there. Now we can keep that while pushing. In push you can keep. And by using this, we know that when we are applying a force on this direction, so the object to move this direction. When the object to move this direction, there will be opposite what? Here, this direction, static friction is there. Fs. Now Fs is equal to mu Sn. This is what a static friction formula. And here we are using n push, so you can put push. Now you see Fs equal to mu s. Instead of this n push, you can put mg plus f cos theta. So mg plus f cos theta. This is what while pushing an object, what happened means greater force needs to be applied to move this object. So you see, so we need to, now the static friction is also what? Larger, so we need to apply more force on this object to push this object. And the same thing, assume that the same object now, you know, downward what will be there? Mg is acting. Upward what will be there? The upward is acting is normal force. Normal force. Now you see in the same thing, now I am pulling this object. Pulling means now also there is a force this direction. But now what is happening means this force is on this direction. You are pulling backward, pulling, not pushing. So force is acting this direction. Now what happened means this force, again you see it is at an angle theta. Now it is splitting into two components. This is perpendicular component f cos theta, and this is what f sin theta. Now pulling the object. You see, while pulling the object, upward force is what? A normal force and f cos theta, downward only mg. So that you can write the equation upward is n plus f cos theta. Upward is. But downward is only mg. So now pulling times n pull you can use. So n pull is equal to mg minus f cos theta. Now you see downward force is reducing, so that it will be very easy to pull an object more than pushing an object. So this is what about pushing and pulling, and you can draw the free body diagram as well. Now for this free body diagram, you see this is a block. This block only I am putting this as a point mass. Downward what is there? mg. Upward normal force. Now what this force? So this is in the direction you see like this. So it is going like this. F. Now you see opposite what is there? Friction is there. So opposite friction. This is a free body diagram for pushing an object. Now pulling an object, free body diagram you see. Now this is a block. This block only I have put it as a point mass. Downward mg, upward normal force. And now you see force backward direction. So force is in the backward direction. Now friction. this direction it moves, no? So this direction it moves, so friction will be opposite direct. So friction will be, so you have to draw this one not like this. Okay, so I will draw again. So this is a block, this is a normal force, this is mg, so mg normal force. Now force this direction, so little at an angle theta you have to draw. This is force. Now friction this direction, this is what F force. So this is a free diagram for pulling an object. So next we can see is this is what about the object to move an object. Push or pull an object means which one will be easy? Yeah, pulling an object will be easier than pushing an object. So next we can see is a new topic about the angle of friction. Angle of friction. So first you have to know what is this angle of friction. Angle of friction means it is the angle between, you see, assume that this is a horizontal surface, one object is there like this, you are applying a force on this direction, so this direction you are applying a force, so that now the normal force is like this. This is a normal force. So when you are applying the force this direction, this is normal force, opposite friction will be there. This is what a friction is. Okay, Fs maximum you can use. Okay, frictional, maximum frictional force. Now you see this is a resultant force, or you can keep resultant force. Now this angle is theta. This angle is theta. So what is this? So this is the angle of friction and the theta you can tell. So the angle of friction means how you can define means this is the angle between normal force N and the resultant force R of this water, normal force and maximum frictional force. So you know that this R means what? It is the resultant of this normal force N and this maximum frictional force. That is what this angle of friction is defined as, the angle between the normal force and the resultant force. Angle between, you see the angle between normal force and the resultant force, and what? It is what? This resultant force means it is what? It is for this normal force and the maximum frictional force. Now there is a small derivation, and first you can find out the resultant force. Resultant force. We know this thing, resultant force, how to find out. R square is equal to A square is equal to B square plus C square. That form you have to use. A square is equal to B square plus C square form. So here we are taking R square. So I am taking this one square, R square. So that what will come? It is equal to this one square plus this one square. So that Fs maximum square plus N square. Okay. Now R is equal to what you can write? Root of Fs maximum square plus N square. So I have taken the square that side, that's what it comes as a square root. Now we know that frictional force formula, Fs maximum will be, the formula will be what? Is equal to mu Sn, the formula. Now we need to find out from this from this equation what I am going to write is mu Sn is equal to Fs maximum. So mu S is equal to what? Fs maximum by n. Now remember this thing. This is what frictional force formula, and from that I have taken what is mu S. So mu S is equal to what? Fs maximum by n. Now what we have to do means we have to find out the magnitude or we can tell that the coefficient of static friction we can use. So while finding the magnitude, we know that we will take this angle. So here this is a theta, and you can take tan theta. When you are taking tan theta, this you can consider as what? This you can consider as opposite side, and this you can consider as adjacent side. So this is theta. For this is opposite and this is adjacent. This opposite is equal to this one. So here Fs maximum means here also Fs maximum. Now you can take tan theta. We know that tan theta is equal to opposite side by adjacent side. So tan theta is equal to what is opposite side? Fs maximum. Fs maximum divided by adjacent side. Adjacent side is n. So what is this Fs maximum by n? It is equal to the mu S. It is equal to mu S. So that you can write tan theta is equal to mu S, because Fx maximum by n means it is equal to mu S. So we got the coefficient of static friction, mu S is equal to tan theta. So this is what this derivation. So you can derive this, you can tell that, you can define this. What mu S is equal to tan theta means, you can tell this is what the coefficient of static friction. So the coefficient of static friction is equal to the tangent of the angle of friction. That is how you can define this. So again you can go through this. So first thing you have to write the definition. Angle of friction means what? Angle between the normal force and the resultant force. And what is this resultant? It is a resultant of what? The normal force and the force. Static friction, maximum static friction. First you have to find out the resultant force by using a square is equal to b square plus c square form. So r square is equal to b square plus c square we are taking. So that if you are taking this one and this one, so Fx maximum square plus n square, and from that r we are finding. So we got the resultant. Now we know the static friction formula. Fx maximum is equal to mu Sn, and from this formula I am taking this mu Sn this side, mu Sn. This is mu S, this is n. Now this mu Sn is equal to Fx maximum. Just I am taking both sides, rearranging only. Now mu S is equal to what? Fx maximum by n. Now we have to find out the magnitude by using the theta angle. So that the tan theta I am taking, tan theta is equal to opposite side by adjacent side. So this is a theta, this is opposite side, and this opposite side is same as the maximum frictional force side, this side. So here we can put Fx maximum, and you know this thing, this is a normal force, this is the adjacent side. So fx maximum by n, and what is this fx maximum by n? It is equal to mu s. So mu s is equal to tan theta, and this is what angle of friction. And this, how we can define this formula? It is coefficient of static friction, and it is equal to the tangent of the angle of friction. And my dear students, this angle of friction is an important question, 3-mark question. So very important 3-mark question. Also this derivation, moving an object, pushing or pulling is easier. It is a very important 3-mark question, and this is what I gave today's assignment. All of you do this assignment and submit on this week. Ask your doubt and interact your doubt with your teachers during the Zoom class time. So thank you all. Bye bye.